Free fall is the motion of objects under the influence of gravity alone. In this video, we'll explore how objects move when only gravity acts on them and understand concepts like acceleration due to gravity and terminal velocity. Free fall is defined as the motion of an object under the influence of gravity alone, with no other forces acting on it. This means there is no air resistance pushing against the object, and gravity is the only force causing it to move. In ideal free fall conditions, like in a vacuum, objects fall without any opposition to their motion. The acceleration due to gravity, represented by the symbol g, has a value of 9.8 meters per second squared. This is a constant acceleration that all objects experience when falling freely near Earth's surface. Remarkably, this acceleration is the same for all objects regardless of their mass, whether it's a feather or a bowling ball in vacuum conditions. Free fall motion has four key characteristics. First, the acceleration is always directed downward toward Earth's center. Second, the velocity of the falling object increases by 9.8 meters per second every second. Third, this motion is independent of the object's mass, meaning a feather and a hammer fall at the same rate in a vacuum. Fourth, the motion is reversible, with the same acceleration acting whether an object is going up or coming down. There are three fundamental equations that describe free fall motion. The first equation, v equals u plus gt, relates final velocity to initial velocity, acceleration, and time. The second equation, h equals ut plus 1/2 gt squared, gives us the displacement or height. The third equation, v squared equals u squared plus 2gh, connects velocity and displacement without involving time. These equations are essential tools for solving free fall problems. Let's work through an example. A ball is dropped from a height, and we need to find its velocity after 3 seconds. We're given that the initial velocity u is 0 meters per second, gravity g is 9.8 meters per second squared, and time t is 3 seconds. Using the equation v equals u plus gt, we substitute the values. V equals 0 plus 9.8 times 3, which gives us 29.4 meters per second downward. There's an important distinction between ideal free fall and real-world motion. Ideal free fall occurs in a perfect vacuum where there's no air resistance and only gravity acts on the object. However, in the real world, air resistance is always present in our atmosphere, meaning multiple forces act on falling objects. This atmospheric effect significantly changes how objects actually fall on Earth. Air resistance is a force that opposes the motion of falling objects and reduces their acceleration below 9.8 meters per second squared. The magnitude of air resistance depends on three main factors: the shape of the object, its surface area, and its velocity. Objects with larger surface areas or irregular shapes experience more air resistance, while faster-moving objects face greater opposition to their motion. Terminal velocity is the maximum constant velocity reached by a falling object when air resistance equals the gravitational force. At this point, the net acceleration becomes 0 because the upward force of air resistance perfectly balances the downward pull of gravity. Once terminal velocity is reached, the object continues to fall at this constant speed without accelerating further. At terminal velocity, two forces act on the falling object. The gravitational force pulls the object downward, while air resistance pushes the object upward. When these two forces become equal in magnitude, the net force becomes 0. With 0 net force, there is no acceleration, and the object maintains a constant velocity. This equilibrium condition defines terminal velocity. Different objects reach different terminal velocities based on their properties. A feather, with its large surface area and low mass, reaches a terminal velocity of only about 2 meters per second. A basketball, being denser and more aerodynamic, reaches approximately 20 meters per second. A skydiver in free fall, before deploying a parachute, can reach terminal velocities around 53 meters per second. These examples show how object characteristics dramatically affect terminal velocity. Let's summarize the key concepts. First, free fall occurs when only gravity acts on an object with no other forces present. Second, all objects accelerate at 9.8 meters per second squared in a vacuum regardless of their mass. Third, air resistance opposes motion and causes objects to reach terminal velocity. Fourth, terminal velocity is achieved when gravitational force and air resistance balance each other, resulting in constant velocity motion. Understanding these principles helps us explain motion under gravity in both ideal and real-world conditions.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.